Okay, so today we're going to do problem 260, and 260 is a problem where we're given a force vector 80 pounds. We're given these angles here, and what we're looking to find are the components of this vector. So this fx here, this fy, and then this fz is what we're trying to find. So I'm going to write this out. What we know that F equals 80 pounds. We know alpha, which is 60 degrees, and we also know that beta is 45 degrees. Alpha is the angle in between the vector and the x-axis. Beta is the angle between the vector and the y-axis. So what are we finding? All those components, so fx, fy, and fz. And if we add all these together, fx, fy, and fz, we should get this force vector of 80 pounds. To kind of make this a little more clear, I'm going to start my analysis by just doing a kind of simple example that hopefully makes this more understandable. So if we have just a 2D example here, and we have a vector, and let's say that's 80 as well, and this angle between the vector and the x-axis is 30 degrees. Okay. And if we want to find the force vector along the x-axis, the x component of this would be something like this, fx. I think you can see that to do that, we would say fx is nothing other than 80 cosine 30 degrees. Okay. Now let's say if we wanted to find fy, all right, the force vector along the y-axis here, all right? Well, there are several different ways that we could find this, right? I think the easiest way is to notice that these angles add up to 90 degrees, so we know that this is 60 degrees, right? So that you could go 80 cosine 60 degrees, and that would be your y component, your fy here. You could also do 80 sine 30, but let's not get into that. But another way to do that is we know that using Pythagorean theorem, we know 80 squared must equal fx squared plus fy squared. So if we've already figured out fx, we can put it into this equation and solve for fy. Okay. So let's remember that when we go to 3D. So let's not let the 3D part of this problem intimidate us. Okay. So we have the angles between fx, or the x, between the vector and the x-axis, as well as the angle between the vector and the y-axis. And we can easily get fx and fy. So we know that fx is just equal to f cosine alpha, and we know fy is just f cosine beta, right? So that's 80 cosine, and alpha is 60 degrees. So we know that is 40.0 pounds, right? And for fy, we have 80 cosine 45 degrees, right, which comes out to 56.6 pounds. All right, so those are two of the things that we need, so we could circle those for our answers. All right, now we haven't figured out fz. And thinking back to the 2D problem, right, we can use this kind of Pythagorean theorem here to figure it out. So what we have is our total vector f squared must equal the fx component squared plus the fy component squared plus the fz component squared. So this Pythagorean theorem here, all right, and we know that this value is 80. We've already figured out fx, which is 40, and fy, which is 56.6. All right. Let's go back up to the problem. All right. So, subbing all this in, we have 80 squared equals 40 squared plus 56.6 squared plus fz squared. So we can rearrange this any way we want. So we would move everything to the other side and take the square root here to find out fz, and fz comes out to be 40.0 pounds. All right, and just to double check our answer, we could put this back in here. 40 squared plus 56.6 squared plus 40 squared should equal 80 squared. All right, and that's it. That's 260.